Hello student, in this video we will be discussing about types of SSB-SC and power calculations. Single sideband suppressed carrier modulation SSB-SC. In SSB-SC we are having two types. One is SSB-RC, another one is SSB-SC. What is SSB? What is SSB-RC, sir? What is SSB-SC, sir? Anyhow, single sideband reduced carrier. Single sideband reduced carrier, single sideband suppressed carrier. This is also called pilot carrier also. What is this thing, sir? First let me see the SSB-RC. Single sideband reduced carrier means in this one we are having single sideband, any one of them, along with a highly reduced carrier, that is also called a pilot carrier. Why we are having that highly reduced carrier? Because how we are demodulating SSB-SC? Anyhow, for the SSB-SC demodulation we are having, what is the point in the synchronous detection I told? We need exactly the same local oscillator having same frequency and phase. It has to stabilize with the received carrier. Are you understand my point? So in the local oscillator we need a highly stabilized local oscillator which has to matching with the received SSB-SC carrier. In olden days, maintaining that one is a problem. We don't have such type of devices at that point. So maintaining that highly stabilized in the local oscillator also, of course in the receiver, is a big cost and is a big problem. In the transmitter side, anyhow we have to maintain. But the same, this much of circuit you cannot keep in the receiver now. You can see the FM mobile station, radio station transmitter and see in your mobile how much is the receiver. So at the time what they are using is, they use a SSB-SC, RC itself is SSB-SC, along with the sideband they are sending a reduced carrier, highly reduced carrier in the receiver side. That carrier is locking and that we are using as a reference for the local oscillator. Then both are matching, you will get the proper output. But nowadays with the development of a quartz-driven crystal, now we are using SSB-SC itself is SSB, because in the local oscillator now with that quartz crystal we can maintain a stable frequency for the local oscillator. Are you understand my point or not? Now, what is SSB-SC, sir? Single sideband suppressed carrier, or this is also called another name, true SSB. And here also we are using sometimes pilot carrier, especially in the point-to-point communication, where we are using SSB-SC for transmission of voice. Understand my point? Single sideband suppressed carrier, also called true SSB-SC. Nowadays we are using this, and this is in this one also pilot carrier we will use in the point-to-point communication, especially in between those 2 points. And for the voice signal transmission, SSB-SC we are using anyhow. Clear? Now we are going to calculate the what is the percentage of power saved in in SSB-SC modulation when compared to amplitude modulation. What I am doing? Percentage of power saved. What is the singleton expression for AM? The singleton expression for AM is AC cos 2 pi FCT plus AC mu by 2 into upper side band 2 pi into FC plus FM plus AC mu by 2 into cos 2 pi FC minus FMT. Are you following my point? The singleton expression of AM is AC cos 2 pi FC additional carrier, AC mu by 2 cos 2 pi FC plus FM upper side band, AC mu by 2 into cos 2 pi FC minus FM lower side band. Now follow. What is the singleton expression of a SSB-SC? In SSB-SC, we are having either upper or lower side band. Upper side band means FC plus FMT. Lower side band means FC minus FM. Now, try to compare this SSB-SC with the AM expression singleton. If you compare, what are the powers saved in SSB when compared to AM? When compared to AM, the power saved in SSB-SC is, we are saving AC cos 2 pi FCD, additional carrier and any one of the side band. So, the percentage of power saved in SSB-SC when compared to AM. What is the common formula I told? Power saved by total power. What are the powers saved in SSB? Carrier plus any one of the side band, maybe upper or lower, out of the total power in AM. So we can write this is PC plus any one of the side band is PC into mu square by 4, any one means. PT means PC into 1 plus mu square by 2. Percentage means into 100. Now take the LCM, cancel the similar terms. What you will get? PC if you take common, it will be cancelled. Here 4 is the LCM. So 4 plus mu square. And here 2 comes in the numerator. So another 2 remaining because that is a 4. So 2 take LCM, 2 plus mu square. Percentage means into 100. This is the percentage of power saved in SSB-SC when compared to the amplitude modulation. Regularly the problems are asking from this one. Even in the 2020 ESC examination also the problem given. Let's see what is the problem is given. And you have directly remember that. Are you understand? For example, if mu value is 1, so for 100% of modulation, 4 plus 1 square by 2 plus 1 square, 4 plus 1 5, 5 by 3, and anyhow 2 is there. So 5 by 2 into 3 will be 6, 5 by 6. Are you understand my point? So 5 by 6 means approximately some 83% you will get. That is for mu equal to 1. But they will give you different values of mu. So remember that and substitute there, you will get it. Let's see the problem. When the carrier and one of the side band, not side bands, one of the side band are suppressed in an AM wave modulated to a depth of 50%, the power saving will be. Carrier and one of the side band we are saving means what? SSB-SC. So the power saving in SSB when compared to amplitude modulation is asking. What is the formula we have? Percentage of power saving equal to What is the formula we got just now? 4 plus mu square by 2 into 2 plus mu square. Efficiency means into percentage means into 100. Substitute that value. If you substitute that value, 4 plus mu value is 0. Whole square by 2 into 2 plus mu, that is 0.5 whole square. Percentage na into 100. Then if you calculate how much will come, this is 4.25 by 2 plus 0.5 whole square, 2.25 into 2, so 4.50. Just a division only you have to do because no calculator allowed. 425 by 450. Are you getting my point or not? Then you will get 94.444 like that. So you can say 94.44%. Just 420 by 450 normal division you have to do. 9 and 4 will come. Understand my point? See the problem. The power contained in single sideband in amplitude modulation is the power contained in the single sideband. Are you getting my point? What is the total power in AM, sir? The total power in AM PT equal to PC into 1 plus mu square by 2. Here in place of mu, they given M modulation index, which is nothing but PC plus PC into M square by 2. Also I can write, where M means mu modulation index. Still if I write clearly PC plus PC into M square by 4 plus PC into M square by 4. What's our actual total power PT equal to carrier power plus USB 1 power plus LSB 1 power, or USB plus LSB, that's it. If multiple components are there, I can say like that. Now here, he is asking in single sideband. How much is in single sideband? PC into M square by 4. Any of the sideband, you can see any of the single sideband, PC into M square by 4. Now the answer will be option C. If a total sideband means add the both. PC into M square by 2 is total sideband power. Single sideband means by 4. Clear?